Hey there, Biotech Girl here. Today we're gonna be talking about plasmids. I'll be covering other topics in other videos, so this is just like basic concepts about plasmids. What is a plasmid? What parts it has? And why is it useful for? What organisms have plasmids? And so on. So without further ado, let's get started. A plasmid is nothing but a piece of DNA, okay? It's nothing but genetic material that can be used, that has the instructions to make a protein to basically do everything that life does. However, not every single organism in Earth has plasmids. Actually, there are only a few of them, like talking about prokaryotic organisms, we have bacteria, they have plasmids, and talking about eukaryotic organisms, there are plants and yeast sometimes. So, this is how plasmids look like in a bacteria. We are oversimplifying this, of course. There are many other organelles that bacteria have, but in general, this is how it looks like. Plasmids are circular pieces of DNA. Their bacterial chromosomes are also circular, but they are in another area of bacteria, so they are replicated and they are used in a different way. So they actually say that plasmids were an evolutionary mechanism, so bacteria can transfer information between each other in order to survive, basically. Now, what are the parts of the plasmid? This is actually a screenshot that I took from Benchling when I was designing my own plasmids. However, please don't feel intimidated by all of the components. This is actually kind of easy when you actually understand the basic topics. So let's go ahead and learn about the parts of a plasmid. The first one that we should take into account is definitely the origin of replication. The ORI, the ORI, is useful so bacteria can replicate the plasmid, can make more copies of it. So if you are designing plasmids in Benchling or any other plasmid design platform, then please don't erase this part, because otherwise you won't be able to really use the plasmid. Then the other thing is the promoter. So when we have a gene of our interest, for example, GFP, we wanted to make bacteria glow. GFP stands for green fluorescent protein. If we wanted to use that gene, if we wanted it to work, then we need a promoter. And a promoter is nothing but a piece of DNA within the plasmid that tells the bacteria that it should start transcribing that gene. You know, the central dogma, which is transcription and then translation. Transcription makes a copy of the DNA, turns it into an mRNA, and then translation turns that mRNA into a protein. So that's basically it in simple words. Then another component of a plasmid, another part that we should really take into account, are restriction sites. And restriction sites are nothing but sites, parts of the plasmid that can be recognized by restriction enzymes. And restriction enzymes are molecular scissors. This is why we have some scissors right here, because we will want to be cutting, copying, and pasting DNA. This is part of molecular cloning techniques. Basically what allows us to leverage DNA and plasmids for synthetic biology purposes and so on. I'll be covering that in future videos, but for now just remember that restriction enzymes cut DNA, and the restriction sites are the places that restriction enzymes can cut on. Finally, we have the antibiotic resistance gene, and this is very useful as well. It also evolved with bacteria so they could survive in antibiotic environments. So for example, in the early days of medicine, scientists discovered that bacteria could create antibiotic substances that would allow them to survive. And so we can actually use this in our times to select for bacteria that actually got our plasmid. So say we are culturing bacteria in a dish that has growth media, and then we genetically modify it, then we'd like to put that genetically modified bacteria into another dish that has an antibiotic, because our plasmid would have a plasmid with which we genetically modified bacteria would have this antibiotic resistant gene, which would allow it to grow even in a dish that has an antibiotic. And so we would know if our experiment worked, in simple words. I don't know if that was actually simple, but please let me know if you like this video. I won't say give it a thumbs up, maybe a loom or not, but I'll see you in the next one. Bye.